My name is Pranesh Kumar. I am the group leader.
My name is Krishna Chan. I am the hardware leader.
My name is Pritesh Reddy. I am the hardware engineer.
My name is Vinay Prasad. I am the software engineer.
My name is Joseph. I am the software engineer.
We are EE312. Our project is based on an Junction traffic light system, as you can see here.
We will be using Omron PLC controller controlled by Swin 3.4.
Our system has two scenarios. The first one is the daytime and the second one is the night time.
In our daytime traffic flow, it's in a closed loop, and the pedestrian crossing acts as an interrupt.
Lastly, in night mode, the lights are activated through magnetic sensors.
These scenarios will be discussed as follows later on.
Okay guys, this is I'll be discussing on our hardware setup. As you can see, this is our setup. This is our RS cable, and it's connected to the CPU. This is our power input to the PLC. We are using a CPM2A PLC, and it has two extensions, 20EDR1 and 20EDR. These are our inputs, and these are our outputs. These outputs are connected to LEDs, switches, and the magnets. And these wires are followed at the back. This is the magnet which helps in detecting the cars, and this is LED which are connected with registers and which are followed to the PLC. These are all switches or pedestrian crossing switches, and that's it.
Hi guys, firstly I'll be demonstrating on the daytime application, which is 4 phases, as you can see here. This one is the first phase, followed by the second one, and this one is the third and the fourth one. For phase 1, line 1 and 2 and 8 are available. For moving line 1 can move straight into C3 and also into line C4. Line 2 will turn into C2 and line 8 will move into C1. Similarly, it is for the other phases. As you can see in the phase 2, line 3, line 4 and line 2 is activated and can turn into its respective junctions. The similar turning procedure is for phases 3 and phases 4. Now moving on to the actual demonstration here. As we run our system, the daytime activates and all the 4 phases move in the clockwise closed loop cycle. As you can see, when there is a change in phase, line 8, 2, 4, 6 remain green, as it will be used in the following phases. The amber light acts as a warning for the driver to stop, hence we have allocated like 3 seconds delay for the amber light. As you can see, there is a change in phase from C1 to C2, and from here it will change phase again to C3, as you've just seen it. So the entire cycle goes in a clockwise direction for one entire cycle.
In addition to the daytime, we have implemented a pedestrian crossing. When a crossing is available, we have also allowed the appropriate lane traffic to flow into its respective intersection. This feature was added to allow more traffic flow regardless of the pedestrian crossing being used. Here is an image for this interrupt feature. When S1 is pressed, C1 and C2 is available for crossing, and lane 7 can move into C3 and lane 6 can move into C4. A similar situation is for the other push button, as you can see here. Moving on to the demonstration of the crossing. For example, if switch 2 is pressed, it will wait for the day timer cycle to end at C4. Then only the C2, C3 crossing will be available for the pedestrian. As you can see, now the crossing is available for C2 and C3. After 10 seconds, the pedestrian crossing will turn red and the normal daytime operations again for show for S3 and S4. Now for S3. It completes its cycle. Then only the pedestrian crossing will be available for pedestrians. As you can see, the switch crossings are available for C4 and C3.
Furthermore, moving on to the night mode, in night mode application, traffic flow is only activated through magnetic read sensors. Usually all the function lights are red and the 4 crossing lights are green, as you can see. When a car approaches the junction, it activates the magnetic sensor and the pedestrian crossing lights turns to red, along with other intersection lights, and giving way to the junctions where the magnet is sensed. In night mode programming, we have also included a function called interlock function. This function operates when there is a scenario whereby 2 cars are approaching the different intersections simultaneously. This feature gives priority to the first approached vehicle, while the other is waiting. Once the first approached vehicle has passed, the second car at the different intersection can move. For example, a car approaches at C1 and the other car approaches at C2. Line 1 and line 2 is moving while the car at line 3 and line 4 wait for it to pass by. And later on, line 3 and line 4 is able to cross the intersection, as you can see. After it has crossed, it will move back to its normal state, where all the junction lights are red and the pedestrian crossings are available.
I'm Vinay. I'll be talking about the C-Swing, since we are using the C-Swing to control the PLCs. As you can see here, there's the ladder diagrams. We're using the keep function, the interlock, and also the timer function. So here's the timer function. We are also using the block manager system. Each block manager system, it contains 4 mains. Each main consists of 13 networks, which uses interlock, timer, keep function, and it's the outputs of different lanes. There's a monitoring mode demonstration for it. As you can see here, this is the monitoring mode demonstration for the night version. This is for C1. As you can see here, when you run the software and also see it in the monitoring mode, so when you place a magnet, it detects it, and you can see the outputs, the green outputs for lane 1 and 2. As you can see here, this is the monitoring mode for the timer. As you can see, for the timers, it starts from its initial value, goes down to 0. It's for each timer is allocated for each different lanes. As you can see in network 3 and network 4 there's a timer is counting down at the moment because the lanes are changing. And you can see it's network 6, the timer is counting down, it will go to 0, then it will go on the next timer. As you can see here, this is the block manager for the day timer. As you can see, there's main 1 to 6, there are 6 mains used in this. It also consists of the main 2 for main 2, main 3, main 4 and main 5. That is for the interrupt for C1 to C4. And main 6 is the output.
Thank you for watching this video. Binaka.